Hello again. As you know, I am Eli, the computer guy, and today we are going to be having a class on Edge Computing Introduction. Edge Computing Introduction. Now, if you don't know why I'm focusing on the computing portion of this title, it's because my wife has gotten addicted to this Netflix television show called Orange is the New Black, and we just finished up season 1. And if you've watched that show, you will understand why I'm focusing on the computing here. The computing. just to be clear. So what are we talking about when we're talking about edge computing? Basically today what we're going to be talking about is the idea of what is called pushing intelligence to the edge of the network. So back in the old days, all the computing power was done by a main server. So really back in the old days you had mainframes with dumb clients, dumb terminals. Those dumb terminals basically were simply a screen and an input device. All the computational stuff actually happened back at the main server, right? You then fast forward, into the 1990s, and we get into the whole idea of client-server architecture. Once you get into the idea of client-server architecture, the clients have more intelligence, but still a lot of the processing power is still done on the server itself. So the server is really where all that intelligence is. Now we get into the modern world. We get into the 2015, 2016, going into the future, when we have a world of the Internet of Things, or the Internet of Everything. Now we have just thousands and thousands, millions and billions of devices, and if they try to send all the data back to a central server for computations to happen, it just functionally wouldn't work. There would not be enough bandwidth to allow all of these devices to communicate constantly with servers. The servers themselves would get overloaded. It would be a big problem. So a number of years ago, there was the idea of pushing the intelligence to the edge. So instead of having main servers do all of the processing, why don't we have all of these edge devices do computational stuff, and then only send the results back to the server. So whereas before, basically, all the devices sent all the data back to the server then dealt with all of that data and created some kind of output. Put it into a log file, put it into a video file, did something with it. Now the idea is that these edge devices, they're actually doing their own processing and computations, and then they only send their output from those computations. So let's say if we had digital surveillance cameras, right? So digital surveillance cameras is something good for edge computing. So before we had dumb surveillance cameras. They were out there on the, wherever they were, and they constantly sent data back to the DVR, digital video recorder, or possibly NVR, network video recorder. Then in that video recorder, there was a setting that stated when video should actually be saved to the hard drive. So 24 hours a day, 7 days a week, all the video is getting streamed back to the server, and then the server decides what to do with that video. Not too bad back in the old days, but now as we start to get so many surveillance cameras out there, there is so much data coming back to the server, there was the idea of what if we could actually put that intelligence into the surveillance camera itself. So instead of the surveillance camera streaming data 24 hours a day, 7 days a week, why don't we put intelligence in the surveillance camera so the surveillance camera only sends data when there's motion? So before, it was the server would only record video when there was motion. Now the camera will only send video when there's motion. Once you get into this, once you start putting that intelligence on the edge of the network, then allows you to be able to put many more devices on the network without having so much load on your systems to actually have everything come crashing down. Because again, even in the modern world, the modern world is a lot nicer than it used to be. Because gigabit per second connections are very easy, very inexpensive to get. 10 gig, 40 gig, 100 gig connections are even out there for your network. But even at 100 gigs, you do run out of bandwidth at some point, right? It may be a lot of video cameras. It may be like a lot of video cameras or a lot of devices. But some companies have a lot of video cameras or a lot of devices. If you have super high definition, like 4K video surveillance cameras, and you're in a major campus, so let's say you're Harvard, Harvard, or let's say you're, Johns Hopkins. You have a large facility and surveillance cameras. You may sit there and go, 100 gigabit per second connection. It would take 1,000, high definition cameras to saturate that. And then you go and you look and you're like, oh, well, they've got 2,000. Right? And so by pushing that intelligence to the edge, basically then what happens is that the devices themselves start to have intelligence, so they can decide when to send data or not to send data, and that makes everything a lot easier. So this is the class, and this is what we're going to be talking about today. Now, of course, before we get into the class, sponsors are what pays the bills, and again, our sponsors are very good for you guys because the only sponsors I get are actually useful. Again, you don't see me doing trying to sell audiobooks on here. Got a couple of good new sponsors today. The first one, a lot of you guys would be interested in, is Bug Crowd. Calling all security researchers and pen testers, Bug Crowd pays up to $15,000 per bug in top tech companies. Join the hunt and learn more at bugcrowd.com. Schoolie Mitchell. Schoolie Mitchell's purpose is to increase clients' profit by reducing telecom costs using software and processes at no risk. We only share savings. SchoolieMitchell.com. Plixer. With Scrutinizer and flow data, users can determine what traffic is on the network, who is originating the traffic, and who is receiving it. Plixer.com. Spiceworks, the best online community for IT professionals to help solve your tech problems. Community.spiceworks.com. And finally, Gilware Data Recovery and Backup Solutions. Gilware's partner programs help computer repair and IT professionals make money by offering data recovery and backup services to their customers. Gilware.com. And as I always say, I do not care if you subscribe to my channel. I do not care if you thumb me up, thumb me down, give me a comment. What I do care about is those sponsor links in the bottom down there. Click on those. I tell you guys what I want, and what I want you to do is click on the links, follow through, download, play with, learn about. These are all good tech companies. Definitely take a look at them. And with that, let's get into what is edge computing. So again, as I was talking about before, the basic concept of what edge computing is we are pushing intelligence to the edge of the network. So those devices that are out on your network now are actually intelligent. So back in the day, back in the day of 2005, if you had devices on your network, they were essentially stupid. They were dumb. They were dumber than dumb. They were like dumb, and then they had a frontal lobotomy, and then somebody beat them over the head and dropped them off a cliff or something, right? These were like, there was no intelligence in devices way back when, right? So if you dealt with a printer, remember back in the day when printers were just printers? Like, in order to make a printer do anything other than a self-test, and you had to plug it into something else in order to function. You have printers, you have, you have surveillance cameras. So surveillance cameras back in the day, it used to be an analog signal over a coax cable. There was no basically what happened with surveillance cameras back in the day is you put them on the wall or whatever. You made sure they were in focus. You might set a couple of things like brightness and auto iris and all that kind of stuff. And then that was it. And then once they were turned on, once you put the power in, they were streaming video 24 hours a day, 7 days a week. There was no intelligence there. Surveillance cameras, telephones, right? So telephones, not that long ago, digital or analog telephones that were sitting on your desk. No intelligence. Now the idea is that since we've come to a converged world, right? So I was talking about convergence before, so everything's on TCP/IP, everything's on the Ethernet standard, that now all of these little devices actually have little computers built into them. Since they have IP addresses anyway, the thought is, well, can we put some more stuff in here? Since they already have to have an IP address, and they basically all have to have a little tiny web server in order to be able to access them, what other stuff can we layer on top? And now what's really cool with this is the price of computing has come down so much that actually pushing intelligence to the edge is an economically viable thing. So when I first started hearing about pushing intelligence to the edge, this was back in the day when like Atom processors were brand new. And so, Atom chips, Intel Atom chips, I mean, they still cost like $30 a piece just for that little chip. So the idea of, adding at least $30 onto these devices just seemed like a ridiculous thing. It's like, yeah, okay. Again, even if you could put some intelligence in a surveillance camera, if you're going to be putting out, 100, 200 cameras, do you really want to increase the price by, thousands and thousands and thousands of dollars? Screw it, I'll just take a dumb camera. Well, the thing is now the price of computational hardware has come down to the point that you can go out and buy a Raspberry Pi. See, most people know what a Raspberry Pi is. They're the very low-cost computers. They have an HDMI card, the whole nine yards. Well, they have the $35 version, and then they have the $25 version, and now they have the $5 version. It's like a 1 gigahertz processor on this thing with 512 RAM and different stuff. That's for $5. $5. So what's interesting now with this idea of pushing intelligence to the edge is originally the concept was, okay, well, we'll offload a couple of things onto these devices, right? So if you have a surveillance camera, the surveillance camera with very little intelligence can see if there's any motion going on, and then if there is motion, it will send video, and if there isn't motion, it won't, right? So it's like, okay, 9 years ago, that's something one of these little devices can do. Well, the really cool thing now is since the computational power has gone up so much and the cost has gone down, is that you can now have them start to do some really, really, really cool things. So like with the surveillance cameras, now they can actually process things like facial recognition. So not massive databases of facial recognition, but let's say that there's some kind of crime that happens and you have a picture of a criminal. You can scan the picture of the criminal, and that gets turned into a biometric map, and that can just get sent to all of these different devices, all these different surveillance cameras on the network, and then when the surveillance camera sees something that matches that biometric print, at that point it will signal back. Again, if you're dealing with 5 or 6 cameras, this doesn't seem like a big deal, but if you're dealing with someplace like London, right? London has like 100,000 cameras or something like that. Being able to offload this work all onto those devices can be very useful. I've seen things such as like color, where you can actually have color detection and all of this different stuff. And again, so the idea is that these devices now are actually doing real intelligent work, and then sending their output back to the main server. Now, when you're thinking about this, you're kind of thinking like, well, okay, that seems nice. But again, even $5 extra on a device, why does this really matter? And as I've been kind of talking about, this is kind of the history. This is how things looked not that long ago. This is how things looked, 5-10 years ago. As far as things like surveillance cameras or telephone systems or any of that, you have your server, and then you have a few cameras. So like when we were going out there and we were installing surveillance cameras, you might have a 16 camera operation, you might have a 32 camera operation, but it was relatively small, just with all the technology and the cost and all that kind of stuff. And so again, all the computation and all the processing can be done on the one server because it's no big deal. The issue is nowadays is there's just so many devices. Again, where a reasonable sized building could have 100 surveillance cameras, plus access control systems, plus all of these different devices. And so just with the current situation is we're getting more and more and more and more of these devices. And again, even on good network connections, at a certain point you're going to saturate the pipe, right? At a certain point the pipe cannot support any more data. And so as you keep adding stuff on, you start running into issues. What is it? Cisco has said by like something like 2020 or 2025 or something, there's going to be like 50 billion networked devices. And again, even if they're all just sending text files 24/7, that really causes a lot of issues. So why edge computing is important is the big thing is it reduces load on your network. So again, for most of you guys, are going to see edge computing really is in surveillance cameras. Surveillance cameras is the big use case for edge computing. The one reason is it just functionally, it's just the thing, again, like I say, biometric scanning, license plate scanning, all this kind of stuff. It's one of those places where it just makes a lot of sense. And then two, it's because they send so much data back to the server. If you have a high definition stream, a 4K stream is 25 megs per second. Again, you got one camera streaming back to a server. That's no big deal. You got 100 of those or 1,000 of those. You don't want that going 24/7. Again, even if you had like 100 gig pipe, you're still going to be running into issues. So the big thing with edge computing is that it reduces the load on the network. And the next thing is then, of course, it reduces the load on the servers. So if the servers don't have to do all the processing, they can do just individual so the output from the device goes to the server, and then the server only has to deal with that output. It's a lot easier to deal with on the server. Again, even if you've got a 4-socket motherboard, with 12 cores per socket with 500 gigs of RAM, again, if you just have just all these streams just pumping into that one server, you're going to run into issues. At some point, you saturate your resources. And so, again, reducing load on the server can be a very significant thing. And the final deal with the edge computing is it offers a lot of new functionality that you may have simply not had before. So, again, if you're thinking about things like telephone systems, where they can have intelligence, again, built into the telephone system, so they can have their address books built into the telephone system. They can have different functionality built in, and so that's one of the things that really makes the edge computing very interesting, because since the devices themselves have intelligence, then you can start programming what the device should do. Kind of cool stuff there. Problems with edge computing. So one of the questions is like, well, okay, this is good. We're going edge computing, Eli. Eli, we're going edging. No, we're not going edging. No, sorry, that was a bad joke. Oh, what is wrong with millennials? Until I saw Orange Is the New Black, I was all good with millennials. And then I saw the first season of Orange Is the New Black, and I've lost all my faith in millennials. Just gone. Anyways, problems with edge computing. The biggest problem with edge computing, I would say, is that bad configurations are a hell of a lot easier to do. The reason is because now you can go in and you can have really fine-grained configurations for all of these different devices. And again, it might be 5 devices or 50 devices or 100 devices or 1,000 devices. And the problem is, any technology professional knows, is the more fine-grained you can make the configuration, in a lot of ways, that can make things a lot better. But it's also one more checkbox that you might forget to check. Right, if you've got 50 checkboxes, and you got all these different options, and you do something improperly, it's gonna be bad. Again, like I say, is does it when does it record, scheduling, all of these kind of configuration things. And if you screw up one of those configurations, like before, when you had a dumb camera sending the video back to the server dealt. It was a pretty simple setup. It was pretty simple. Now every single camera, every single device has their own configurations, and just think about it. How easy would it be to just not check the right box, or to screw up the scheduling? To say that the camera should record in the middle of the night and shouldn't record during the day, or something stupid like that. The next thing is hacking vector is massively increased with this whole idea of pushing intelligence to the edge, because think about it, these devices are themselves now computers. So you can go, there's the Google of surveillance cameras now online, where you can actually go, there's a website, and it's all like the cracked surveillance cameras all around the world. Well, something to be thinking about is, now that you have surveillance cameras that have intelligence, and now that you have phones that have intelligence, and now that you have all these different devices and things that have intelligence, again, they have web servers built into them. They have this programming and stuff built into them. And so that's now a vector for attack. Not only can somebody compromise your PC, not only can somebody compromise your server, but now somebody can compromise your surveillance camera. And again, that's something you guys need to be thinking about from a security standpoint, is how would you know if a surveillance camera on your network was distributing malware? How would you know if a surveillance camera on your network somehow had subterfuge installed and was stealing all your credentials? How would you know that? Right? So this is one of the things you have to really think. That's the nice part, the old dumb analog cameras, it's either on or it's off. It's either in focus or it's out of focus. That's about it, right? With these new devices, you really do run into problems where, again, they can be hacked, they can be compromised, all that kind of stuff. The final thing, as far as edge computing is concerned, and something you have to think about, is licensing cost. So again, one of the things I keep beating into your guys' heads is money, 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 right? And again, if you don't like money, if you don't like dealing with money, I completely understand. Go off and be a philosopher. Go off, be a florist. Go off and do some other profession. And our profession, the technology profession, it all revolves around money. It's not moral, it's not ethical, just how it is. And so one of the issues you get into with edge computing is you start running into licensing costs. So right before, if you had, let's say, a surveillance camera, and you bought the surveillance camera and you stuck it on the wall, that surveillance camera costs you $100 or $300 or $1,000. Once you bought it, you're done, right? Well, with all this new functionality that's built into all these edge devices, you may buy that device for $200. But in order to get the motion sensing component of the software, that'll cost you another $50. In order to allow both local and remote storage, it'll cost you another $50. In order for this to happen and that to happen and the other thing to happen, and you may find out that you literally double the cost of the hardware in the licensing, because as soon as you have a computer, now you can start doing this whole thing with licensing codes. So if you have the licensing code, that function works, and if you don't have it, it doesn't. And you have to be very careful about purchasing this stuff, because you go out and you look at the spec sheet, and the spec sheet says this camera or this device does all of these things. And it's really easy to miss it does all of these things if you pay an extra $10 for this, an extra $25 for this, an extra $50 for this per frickin' device. And again, once you go out there and you start doing enterprise installs, it's not $50 for 3 devices, it's $50 for 100 or 500. So licensing costs, when you start getting into edge computing, is a huge thing. And this is a big deal for anybody that's moving into a converged network, coming from the old telephone systems, coming from the old surveillance systems, coming from the old access control systems. Those old systems, it was pretty simple. You purchased the hardware, you purchased all the devices, and that was it. Like with telephone systems, you may have to buy some ports for their voicemail, costing an extra couple $100. But that was really, really about it. There wasn't a lot of licensing you had to deal with. You come into this new converged world with edge computing and all that kind of stuff, licensing can just become a complete just cluster insanity. So keep that in mind. Now, everything about migrating to edge computing, which really is the way to go, whether it's now or whether it's in a couple of years, the first thing that I would say is make sure you have centralized management. Big deal, big deal, big deal. Because again, you have all these little devices and they have all these little configurations. And so the question is how are you going to maintain them and manage them and update configurations? If you have to log into every single device in order to get it done, that's going to suck. Again, Microsoft came up with Active Directory for a reason, right? Well, no, they didn't come up. They stole Active Directory for a reason, but that's its own story, right? There's a reason why system administrators use Active Directory, because it makes life a hell of a lot easier to sit down at one server and be able to administer all the user accounts and all the computer accounts and all that kind of stuff. If you have to go to each individual computer to do the configurations, it sucks. Same is true in the edge computing world. If you have to go to every single surveillance camera to do an update, or to change a configuration or to update firmware or something like that, guess what? It's not going to happen. If you have to log into 100 different surveillance cameras in order to do something, it's just not going to happen. Again, part of being a technology professional is understanding the failings of being human, and this is one of the failings of being human. If you have to log into 100 different devices to do something, it's most likely not going to get done, or at least not get done in a timely manner. So you want some kind of centralized management system for any of this kind of edge computing. So again, you can sit down at one console and you can say, okay, I need to update the firmware on all these different devices. Go. And it does it, right? The next thing is the interoperability of equipment. One thing to realize with edge computing isn't really bleeding edge, but it's still a little cutting edge as far as technology goes. And so the standards aren't really solid. They're pretty solid. It's like the standards are kind of like pudding solid. You know what I'm saying? Like, it's solid. If you push on it, yeah, there's some pudding there. Yeah, it pushes back a little bit. But if you push too hard, it kind of goes through. Does that make sense? You know what I'm saying? Like there are a lot of standards out there, and there's a lot of good interoperability, and a lot of people know what's going on, but you can still get into a bit of a mess. You can still get into a lot of weird issues where some devices don't talk to other devices, some things don't talk to other things, so on and so forth. So when you're going to be going out there and you're going to be purchasing your equipment, really look at the interoperability. What devices talk with what other devices, what protocols are used, what are the licensing requirements, all of these kind of things. Because again, you look at two devices, and one's $100 and one's $200, and you go, oh, of course. And you look at the spec sheet, and you're like, the $100 one and the $200 one look identical as far as the spec sheet is concerned. So of course I'm going to buy the $100 one. What you don't look at is that $200 one has been like authorized or approved or whatever by 50 other different hardware vendors. That there's all of this other stuff that goes into it, and so that's one of the things you need to be thinking about. APIs and extendibility. Again, with a lot of these edge devices, you can actually do things like upgrade to them. You can actually you can have different software be able to talk to them and do different things. So like with Axis video cameras, surveillance cameras, you can actually install software onto the surveillance cameras. Couple extra bucks, of course, but you can. So again, pushing that intelligence to the edge, we think about client software, Word and Outlook and web browsers, and you think about server software, Microsoft Exchange or SharePoint or something like that. Now we have these edge device software. Again, biometric software or color determining software or license plate reading software. So if the devices that you buy allow you to upload and install new functionality or have APIs so other servers and things can communicate with it, that will be good all the way around. And then finally, the final question you need to be thinking about with migrating is how much do you trust the support and updates. So this is a huge problem right now with a lot of the devices that got deployed 5 and 10 years ago, where companies simply are not creating new firmware. They're not creating new updates for these devices. And so these are devices that are sitting on the network that are vulnerable to attack, and people simply have decided to not maintain any security updates for them. That sucks, right? And again, especially in an enterprise world, when you're dealing with, cyber espionage, when you're dealing with a lot of these issues, you want to know that whatever company you purchase this stuff from, what is their plan for maintaining all of those security updates, for maintaining firmware updates, and all that kind of stuff. Because if they don't have a plan, or if you don't trust it, I wouldn't put it into my network. So really, the final thoughts are... yeah, edge computing is good. Edge computing is one of those things. It's a really good thing. I would warn you when you're thinking about using edge computing in your infrastructure. Again, edge computing is a little bit like quality of service, where people think like quality service of edge computing are going to fix all the issues for your network. So let's say your network is a little slow, you don't want to do a massive build out, so you're like, oh, okay, well, instead of doing a massive build out on the network, what we'll do is we'll start having these intelligent devices, so they'll have less of a load on the network. The problem that you run into is that there is still going to be a load. There is still going to be a load on your network. Again, if you put out high definition 4K video cameras or whatever, and then they're only sending back video when they need to, most of the time that's fine. Let's say most of the time only 1 or 2 cameras are sending video back to the server. No big deal, right? You got 20 cameras up, only 1 or 2 is sending back. Your 10100 or your gig network is working great. But then what happens is let's say they only send back video when there's motion. And then what happens if there's a big storm? Let's say there's a big storm and it comes through and all the trees are moving and stuff is doing all kinds of wacky stuff. Now all 20 cameras are now registering motion. So that means now all 20 cameras are sending video back to your server. what happens at that point? So that's kind of one of those issues that you have to think about. A lot of people are looking for like cure-all band-aids. I do this one thing and then I don't have to worry about all the other issues. Again, remember, as an IT professional, you have to be looking at the big picture. You have to look at everything that's going on, figure out what your risk tolerance is, all that kind of stuff, and then build out your infrastructure as need be. But overall, again, I would say with edge computing, one is generally a very good thing. Generally a very good thing, and it's where the future is going regardless. So you're on this ride whether or not you like it, but there are a lot of things that you need to be thinking about as an IT professional with it. Again, I mean, it's just infrastructure requirements. What are the infrastructure requirements? What are the security requirements? The licensing requirements, the configuration management, all of this kind of stuff. Because realistically, I mean, like a lot of IT departments, you still think about the devices. You still think about the computers under your care. So I have a department with 100 computers. I have a department with 1,000 computers. But with the Internet of Things, the computing devices that you are going to be responsible for could double, quadruple, even go up to 10 times, right? So now it's not simply that you have to manage all of your computers and your laptops. Oh, now the cell phones, and oh, now the tablets, and oh, now the surveillance cameras. Oh, now the telephone systems, telephones, and oh, now the access control, and then oh, look, the boss has figured out some other thing that needs to come in, and so this is something you have to be thinking about again with this whole converged world and edge computing and all that kind of stuff. How are you going to manage all this? When you go from dealing with 100 computers where you have to worry about antivirus updates and that kind of stuff to 2,000 devices where you have to worry about firmware updates and compliance and all that kind of stuff, it's a different mindset on how you deal with this technology. And it's just one of those things that you got to be thinking about. So again, overall concept, edge computing is great, unless you screw it up. If you screw it up, you can screw it up bad. Edge, is like, it can go bad real quick. But if you set it up right, it should be good. Now, as far as you know, I do have other, as far as you may or may not know, I do have other projects in case you want to see my other videos or talk with me or meet with me in real life. So I have my Failed Normal YouTube channel if you want to see me do vlogging. I have the Eli Computer Guy Live YouTube channel for question and answer videos. I do silicondiscourse.com Skype meetings. So if you want a Skype meeting with me, we get on, we do a 50-minute Skype meeting. I've done like 200 or so of those so far. They've all gone very well. And then the Baltimore area meetup. Woohoo! I just started doing a Baltimore a meetup in the Baltimore area, where basically you get to sit down with me and you can ask whatever questions that you're having about your business or your career development or any of that kind of stuff, and we do it in a group setting so everybody can learn from everybody else's stuff. So that should be good if you want to show up to that. And then sponsors, of course, as I say, please click on the links below because it's what keeps everything going. And finally, I haven't given up. I have not given up on our grade A for YouTube president. Hopefully sometime soon he will become president of our great nation state of YouTubia. But make YouTube great again. And with that, I will call it a day. As always, I enjoyed teaching this class and look forward to seeing you at the next one.